Hello. In this session, we are going to describe the reduction method of metal extraction. Welcome. As you can see on the board, what we have there is a blast furnace. A blast furnace is basically a fireplace known as a kiln. The temperatures within the blast furnace are normally very high as 1600 to 2000 and above degrees Celsius. To begin with, we are going to see what happens when a metal is to be extracted. So looking at the diagram, as you can see, we begin by putting in carbon, and carbon meets oxygen from air. So when carbon meets oxygen from air, the temperatures are fixed at 1600 degrees Celsius. The heating process converts that mixture into carbon dioxide, and then as you go up, the temperature lowers to 1000, then to 700 degrees in the middle, and to 300 degrees Celsius at the top. So once the CO2 has formed, it combines again with carbon, which comes from the top in form of coke. The coke reduces the carbon dioxide into carbon 2 oxide or carbon monoxide, which is a reducing agent. And then at the middle of the furnace, the reducing agent reduces the metal oxide into the required product. And when that process happens, we find that some waste is tapped out in form of slag. Slag is a mixture of an iron oxide, a metal oxide, and silica, which forms a metal silicate. So briefly, this is what happens at the bottom of the furnace, as you're going to see up here. So the main reaction starts at the bottom of the furnace, where we have carbon combining with oxygen, forming CO2. This happens at roughly 1600 degrees Celsius. Next, we have the carbon dioxide meeting coke. And when the process happens, it is reduced into carbon 2 oxide or carbon monoxide. So that is the equation for the reaction. This happens at roughly 1000 degrees Celsius. So once the reducing agent has been formed, inertia, and that shows that the high temperatures are above the melting point of the metal. Now, beyond this, we have an illustration at the top. So the top reaction tells us that there are different ores, namely galena or lead sulfide, zinc blende or zinc sulfide, copper pyrite or ferrous copper sulfide, and then we have iron carbonate. Now, for all reduction processes, there are 3 distinct steps, but there are 2 core steps which involve oxidation and then reduction. During oxidation, each metal ore is roasted in air, and that roasting process leads to the formation of respective metal oxide, namely lead oxide, zinc oxide, copper oxide, copper 2 oxide, In fact, that will be copper 1 oxide, and then also iron 2 oxide. Once these oxides have been formed, it means the metal ores have been separated from their main impurity, which is sulfur. And when that happens, we take them to the next level, which is the reduction chamber at high temperatures. This is roughly at 1000 degrees Celsius. And the combustion is between 1600 degrees to 2000 degrees Celsius. This will be between 700 to 1000 degrees Celsius. So each metal ore has been oxidized, but in the second step, the oxidized ore is being reduced. Reduction is the removal of oxygen. So we end up forming a respective lead, zinc, copper, and iron metals. If the temperatures are high, they will be in molten states. But if the temperatures are roughly 700, they will be in solid states. Now, next, the purification chamber is where the purification occurs. For example, for lead, we can purify it by electrolysis. The same applies with zinc and copper. And when it comes to copper, as you purify it, you'll find that it forms some sludge, which is a waste mixture of silver and gold. Now, when it comes to iron, we can simply get iron by magnetic induction because it is ferromagnetic. So whichever method is chosen for purification will be in respect to the nature of each metal extract. For example, we form blister copper, which has some internal impurities of manganese and cobalt, and that's why we purify it by electrolysis. The final product is a pure extract of each of the metals. Remember, the reduction method for metal extraction is mainly for the less reactive agents, simply because if you put highly reactive metals like sodium, potassium, or aluminium, there will be an explosion. And that is why for the highly reactive metals, we extract them by the method of electrolysis. Therefore, the reduction method of metal extraction is aimed at extracting the less reactive metals, namely zinc, lead, iron, and copper. So that's a brief description of what happens during the reduction method for metal extraction. Thank you.